So when they've given you the answers to a quadratic, remember we solved by factoring. It was one of the ways that we solved a quadratic. And if you solve by factoring, you get the answers by setting each factor equal to 0. So if it gave you the answer of -2, your factor would have had to be x plus 2. If it gave you the factor or the answer of 1, your factor had to be x minus 1. And so then to solve for that, you would just FOIL x times x times -1, 2 times x, and 2 times -1. And then you would combine your like terms, and you should have gotten x squared plus x minus 2 as the quadratic that would give you those two answers. Solving by elimination. For this one, you do need to get either x or y to where it will cancel out. I chose the y just because I already had a negative and a positive, and the numbers were not that much larger. If you had really big numbers one way, I would probably eliminate the other variable, right? So just the easiest variable to eliminate. So I multiplied the top by 4, so I could get this to be -12. And I'm multiplying the bottom by 3, so this would be +12. And remember, when you do that, you have to multiply every single piece. So I'm going to say 4 times 2x, 4 times -3y, and 4 times -12. And then I'm going to say 3 times 3x, 3 times 4y, and 3 times -1. All right. And then at this point, I am ready to just add down. So I can add my 8 and my 9x, -12 and +12, -48 and -3. All right. And then my final step to solve for x is just to divide. So x is going to equal -3. Once you have one of them, all you have to do is plug it back into either one. It doesn't matter which one. So I can say 2 times -3 equals, or minus 3y equals -12. 2 times -3 is -6. Add over -3y equals -6, and then divide by -3. And you should get two answers, an x and a y, -3 for my x, +2 for my y. All right, that is solving by elimination. Solving by elimination. And then the last way it wanted you to solve was Cramer's rule. So Cramer's rule, remember, you have to do your coefficients, 3, 1, 2, and -5. All right, you have to do your determinant. Remember your determinants to multiply this diagonal 3 times -5. And then subtract this one 2 times 1. So my determinant there is -17. I'm going to do the same thing for these. I'm going to say 1 times -5 minus -22 times 1. And then I am going to say 3 times -22 minus 2 times 1. All right. And then I'm going to take my final step here is to take each one of these and divide by this one. So I would say +17 divided by -17, -68 divided by -17. So that means my x value is going to be -1 and my y value is going to be +4. And so that is Cramer's rule. Completing the square. So the first thing I want to talk about is the perfect square trinomial. This is one of the factoring methods that we had. We didn't use it a ton, but this is where we actually get the quadratic formula. All right, and so the reason we're doing this is so that we can actually see where they come up with quadratic formula. Typically, you're not going to use this as much. I'm showing this to you for my guys that will go on to calculus with me, because there will be times when you factor stuff out of a root by doing this method. And so this is a method that you need to know. But in this case, you're going to look and see, do I have a perfect square trinomial? By that, I mean, you're going to look at the first guy and you're going to say, is this a perfect square root? Yes, x squared does have a perfect square root. The perfect square root is x. You're going to look at the last one. Does 16 have a perfect square root? Yes, 16 has a perfect square root. That perfect square root is 4. All right? And then if I were to take these two, x times 4, 4x, and double it, 8x, do I get the middle one? Yes, I do, which means this is a perfect square trinomial. I'm going to use the sign here. If I were to do x minus 4 and square it, then I would get x squared minus 8x plus 16, all right? And I'm going to set that equal to the 49 over there. Now, here's the thing. Now that I've done that, I can actually solve it, because this is just like, you can look at it like, what if I had x squared equals 49? What would you do? You would take the square root of both sides, which is what you do here. On the left-hand side, just like over here, when you take the square root of a square, all you do is get rid of the square. So you have what is left inside, which is just x minus 4. On the other side, remember when you are doing the square root with a variable, you have to consider the positive and negative root. So the square root of 49 is 7, we know that, but we have to consider the positive and the negative 7, which means we have x minus 4 equals 7 and x minus 4 equals negative 7. This is where we're going to get our two answers. So we're going to add 4 to both sides. So x can equal 11 and x can equal negative 3. Those are my two answers. So if you have a perfect square trinomial, you can go straight to that square factoring and then take the square to both sides and you're pretty much done. Just solve that little tiny binomial equals a number, all right? Completing the square means I actually don't have a perfect square. And so I need to consider, how would I make the perfect square? Well, I want to point something out. If I take the 8 and I cut it in half, what do I get? 4, right? And then if I square that, what do I get?
16.
Yes, that's how it will always work out. This middle guy cut in half, squared will be the third guy, okay? And that's going to be a perfect square trinomial. So when you don't have a perfect square, that's how you force one. So for example, if I had this guy equal to something and I wanted to use this method, I would cut the guy that's in front of my x in half. So what happens when I cut the 6 in half? I get a 3, right? So if I cut 6 in half, I get a 3. If I square that 3, I get a 9. That's what I would have to add to the end of that to make it a perfect square so that I could factor it like this. All right? And so we're going to use that method to complete the square so that we can solve by completing the square. So to solve by completing the square, we have to create a perfect square trinomial. All right? And so right now I have an x squared plus a 10x over here, and I have a 15 over here. All I'm going to do is I am going to look at this term right here. 10. What happens if I cut 10 in half? What do I get? 5. And then I square it, I'm going to get 25. So I'm going to add 25 there and I have a perfect square. However, this is an equation. If I add 25 to the left side in order to keep it an equation, what do I have to do to the right side? Right, so I'm going to do this. All right? And so now this side is a perfect square. All right? So I know it's going to factor to be whatever term this was, plus. So whatever this guy was when I cut him in half, that was 10. That's what's going to go here. All right? So I cut that middle guy in half. That's what's there. The other side is literally whatever I added. 15 and 25 gives me 40, right? And so this guy is going to be 40. And so now I can just solve by taking the square root, just like I did in the last section where we solved by taking the square root. Square root of both sides. Over here, you just get what's inside because you're taking the square root of a square. Over here, you do need to simplify, all right? So think about your factor tree, 2 and 20, 2 and 10, 2 and 5. Remember, if it pairs up, it can go out. If it does not pair up, it stays in, and whatever stays in together multiplies. So inside, I'm going to have a 10, 2 and 5, all right? Also remember that you always have that positive negative in front of it. Everybody see? When you take the square root, you have to do plus and minus in front of it. Okay? What's my last step to get x by itself? Yeah, subtract 5. On the left-hand side, I have my x by itself. On the right-hand side, if you have a radical that stays a radical, so like square root of 40 doesn't have a perfect root. Had it been square root of, 36, I would actually solve it for the numbers, right? But I cannot combine -5 and the positive and negative root of 2 squared of 10. So I actually leave it just like that. That would be my answer. -5 plus or minus the square root of 2 squared of 10. Now, here's the thing. If it wants it exact, that is the exact answer. If it says round to the nearest tenth, you put that guy in your calculator and you will have two answers. You would say -5 plus this in your calculator, -5 minus this in your calculator, okay? So if it wants it exact, then you're just going to leave it just like this. If it says round, you're going to have two answers. This technically is two answers, but you're going to have two different decimals that you would have from your calculator. So while these both had a positive 34, positive 15 in my root, it is possible to get one with a negative in the root, which we're going to do with quadratic formula. So if you were to do that, let's say this had been -15 when I took the root. Just simplify that with your I, right? Remember, if you have a negative in your root, you can take it out with an I. So even if, 15 is just 3 and 5, nothing comes out of it. But had it been -15, an I would have come out. And you would have had a positive. You don't want to ever leave a negative in your root, which we're going to do with the quadratic formulas. So you'll see that as well. Quadratic formula. So we are on to section 7. On to section 7 in your books. Quadratic formula, page 213. So I will say I use quadratic formula. That is my go-to. If I cannot very quickly factor it, I use quadratic formula for everything. There is no thinking about it. You really just need to know the formula, and then you can just plug it in, all right? And so if you have something that either is really difficult to factor or cannot be factored, quadratic formula. Completing the square is something that you're going to use probably in a way to get something out of a root, right? And so there are ways to manipulate something in a root so that you force a perfect square, and then you can get it out of a root. But most of the time people will either use factoring or quadratic formula. Those are the two most common methods. If it's really simple factoring, factor it, be done. If it's not really simple factoring and you're stuck on the factoring, then go to quadratic formula, because this one will always work. It is derived by completing the square. So when you see this crazy quadratic formula, it comes from the completing the square method. All they've done is they have put the b over 2a, and they've done all this crazy stuff to manipulate it, and then they've come up with this quadratic formula. But it stems from completing the square. That's where this quadratic formula comes from. The quadratic formula is listed at the top of page 214. You do need to memorize this. You do need to have this memorized. There will be ones that you must use the quadratic formula for. It is negative b plus or minus the square root of b squared minus 4ac over 2a. All right? And so you need to memorize it. All right, so let's look at using the quadratic formula. Using it, just like with factoring, it must be equal to 0. So you'll notice in completing the square, it wasn't equal to 0. It doesn't matter. You actually just want the x squared and the x by itself. But for quadratic formula and for factoring, the first step is that you have to have it equal to 0. It also needs to be in standard form, okay? Which means I need to move this 5x over by subtracting it. It will not combine with anything over here. So we have x squared minus 5x plus 4 equals 0. It has to be in this format. If it is not in this format, you will get your a, b, and c messed up, okay? So the a is the number in front of the x squared. The b, including the negative, is the number in front of the x. And the c is the constant. And that means if that is a negative, then you use a negative. If it's minus 4, you would say negative 4. All right, so you have to use the positives and negatives that are in front of the a, b's, and c's when you plug this in. All right, so then we're going to plug it in. Negative b. B is negative 5. So we say negative 5. That's why you have to do that. Plus or minus the square root of b squared minus 4 times a times c. All of that is over 2 times a. So quadratic formula, you just memorize and plug in your a, b, and c. That is what x is going to equal. So your quadratic formula does not have any x's in it. The quadratic formula is what x equals, okay? It is just your coefficients and your constants that you are using. Once you've plugged it in, you are just doing order of operations, okay? Order of operations says I do my exponents first. Here's the thing, grouping, that radical is a grouping, okay? So I'm doing my grouping first, but within that grouping, I'm doing that exponents, okay? So this is my grouping. My radical is my grouping. Within the radical, I have to do the exponent. Then I'm going to do this multiplication. Then I'm going to do that subtraction. Once you've done that, do your order of operations. Negative, that's going to be a positive 5. Negative 5, anytime you square any number, it is positive. I have 4 times 1 times 4, so that's minus 16. All right. And then all over 2 times 1 is 2. All right. Then I am going to do under the root. So I have 5 plus or minus 25 minus 16 is 9, all over 2. This actually works out. Hopefully you could see that that guy's factorable. Negative 1 and negative 4 would have been factored there. This is actually one I would not use the quadratic formula for, but they're just showing you that it works even for those that you could factor. When you have something like this is not your final answer because 9 actually has a root. If that were square root of 7, you would actually be done here, okay? But you're not done because we have a perfect root here. So you actually need to do the 2 answers for this one. You need to say 5 plus the square root of 9, which is 3. Over 2, and you need to say 5 minus the square root of 9, which is 3 over 2. 5 plus 3 over 2 is 4. 5 minus 3 over 2 is 1, and that is what x equals. Had you factored this guy, you would have done x minus 4x minus 1, and you would have gotten those same answers, okay? Quadratic formula works for all quadratics. So this particular one is not factorable, all right, with integers. You could factor it with roots, but you're never going to think to do that. So again, it has to be equal to 0. And so you're going to move that 11 over. You do want it in standard form, so you want the 4x squared, the plus 12x, and then the minus 11, all right? And then we're just going to plug it in. This is my A, this is my B, this is my C. So negative B plus or minus the square root of B squared minus 4 times A times, that is a negative 11 there, by the way, times C all over 2 times A. All right? Then we're just doing order of operations. 12 squared is 144. We have 4 times 11, that's 16 times 11, which is 160 plus 16, so 176. It is plus because I have a negative times a negative. All right, so pay attention to your negatives here. All right, 176 all over 8. And then, of course, we have to add these. We get 320 over 8. Couple things I want to point out here. 320, if I want the exact, which is what I'm going to be asking for on these, then you have to do your factor tree. So you do need to do 320 and do your factoring here. All right, so factor it. Everything that pairs up can come out. So I have a 2 that can come out. I have another 2 that can come out. And I have another 2 that can come out, all right? If multiple things come out, you multiply them. I have a 5 that stays in. So this simplifies to 8 square root of 5. So I would write that negative 12 plus or minus 8 square root of 5 over 8. All right, how do I simplify this? Here's the thing. You can reduce this, but it has to come out of every number, every integer, okay? And you can only reduce outside to outside. So I cannot reduce, obviously 5 and 8 don't reduce anyway. But if this was a number that reduced with 8, I could not reduce the 8 and the 5. But to reduce the 8, I have to reduce it with the 12 and the 8 on top. So I have to have something that comes out of 12 and 8 and 8. And it reduces all of them, okay? Think of it as factoring out a common factor on top and reducing it with the bottom, all right? So what number comes out of 8, 8, and 12? 4. And so I can divide all of those by 4. I can divide 12 by 4. What do I get?
3.
Yeah, 8 by 4 and 8 by 4. And so my final answer here is negative 3 plus or minus 2 square root of 5 over 2. That is my answer. That is technically 2 answers. If they said round to the nearest, you would say negative 3 plus 2 square root of 5 divided by 2. Negative 3 minus 2 square root of 5 over 2. All right? But this would be your answer to what does x equal. All right? That is your answer to what does x equal. All right, so first rule, make sure it's equal to 0. This guy's equal to 0. And then we are going to just plug it in. Negative b. So negative 10 is just 10. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. And then we're just going to do our order of operations. This ends up being 100. 4 times 29 is, we should subtract 116, I think. Yes. All right, all over 2. All right, so what happens here? Well, when I do this, I get 100 minus 116, which gives me negative 16 in my root. All right? This is an imaginary number. Now, 16 has a perfect root, which is nice. If it didn't, I would just simplify it like I did on the last ones and then take the I out. In this case, it has a perfect root, so this ends up being 10 plus or minus. My root of 16 is 4, and because it was negative, I have to put an I there, all over 2. Now, once again, with complex numbers, you do have to factor it out of everything. You can divide it out. So you could say, well, 10 over 2 plus or minus 4i over 2. That's one way to think about factoring these as well. Usually with the radical, you leave the numerator as a group and put it over the denominator. So that's why you reduce it all together. With complex numbers, you have a real part and an imaginary part. So you can reduce it this way if you want to. This one reduces out of your denominator altogether. So 10 divided by 2 gives you 5. Plus or minus 4 divided by 2 gives you 2i. That is your answer. You cannot combine the 5 and the 2i, so there is no way to give me a decimal approximation of this one. All right, you would just leave it 5 plus or minus 2i. Those are the two answers for what x equals.